Hello, students. I would hereby welcome you to C2219, that is the second year course, that is Statics and Introduction to Strength of Material. My name's, of course, JQ Diungu, who is going to take you for the first component, that is Statics. I'm from the Department of Civil and Environmental Engineering, that is the School of Engineering. First thing first, before we start our business on looking at the first lecture, I would want to go through the course outline.
Basically, this course C2219, it has got a credit of 0.5, meaning we need to have 2 hours contact time, that is for teaching, in a week. Then, of course, we're also going to have 3 hours contact time, that is doing the tutorials. Yeah. Then, of course, the targeted group, it's second year students from School of Mines and, of course, School of Engineering. Then the prerequisite, all of you need to understand, to have the basics, the tools, of course, that are coming from physics 1010, and that is mathematics 1100. As earlier alluded, I will take you through the first part of C2219. Then the second component, you'll be taught by one lecturer by the name of Mr. Lungu. So, what we are going to have here is, from, of course, the past history, because of this outbreak of this COVID-19, there were serious issues in terms of contact hours. Then from your end, students, at the end you complain concerning money for buying data. So what I did last year was I prepare the notes and I do some sort of a video, then I share. You watch and listen to that video at your own time. This also applies to the tutorials. Then, if you have got any problem, you didn't understand maybe one or two concepts, you address that to your class rep. So, if maybe 2 or 3 students didn't understand a certain content, you share that to your class rep. Then the class rep is going to inform me that there are questions. A number of students didn't understand A, B, C, D. Then we find time, we chat. It can be on Zoom, it can be on Google Meet, it can be on Big Group Button, that is under Moodle. So this one being the first meeting and the first class, so most of you guys, you have not yet been enrolled in Moodle. Once most of you guys are like enrolled, we are going to have another session where I'm just going to teach you on how to attempt quizzes using Moodle. I'm sure maybe most of you, the first years, the time you are at NS, Maybe your lecturer also used the same platform, but I know there are others who maybe they have forgotten on how to attempt a quiz
Nice, eh?
on Moodle. So once you are enrolled, we are going to have a session. We go through on how to attempt a quiz, an assignment, and so on. So without wasting much of your time, of course, I'd already shared the prescribed book, which is Russell, the 14th edition, of which all of you guys have. Then for the other component, that is the strength of material, of course, Mr. Lungu is going to share which material you're supposed to use. Then, in terms of assessment, at the end of this term, we are going to have a test which will be rated at 20% towards the final grading. Then the assignment and quizzes, it will also be 20%. Then the 60%, which is of course the difference from 140, that will be the final one. For the tutors, I'll introduce the tutors in the due course. They are still waiting for their contract to be signed. Then once they have their contracts, I'll introduce them. They'll also be part of this C2219 WhatsApp group. Please let us mute our mic. Thank you. So basically today, as our first class, we are just going to look at the general principles and of course just to recall resolution of a force. I'm sure those who passed through NS, there was a component where you were resolving some forces and so on. But there are those who are coming direct from industry, of course, would want to remind them on one or two things that they could have forgotten, so that we move together. We don't want to leave anyone behind. So I shared these notes. Most of you went through. Things are straightforward. So the main objective of this course is to develop in the engineering students the ability to analyze a given problem, of course not any other problem, but engineering problems, in a simple and logical manner, and to apply its solution, of course applying the fundamental and well understood principles. The course is designed for, as I've already mentioned, that is the first component, which is statics and the mechanics of material. This is for engineering students and those engineering students from School of Mines. The main objective of this lecture is, of course, to provide an introduction to the basic quantities and idealization of mechanics. Idealization would just simply mean some sort of a model to make things easier for you to understand, for you to solve those problems. Of course, you can recall Newton's laws of motion. From your physics, you can remember how you could solve those problems where you've been given 2, 3 forces. And again, from the same physics, you could resolve. Please let us mute our mic. Please let us mute our mic. So this is the famous Sir Isaac Newton, who is the source of, or maybe the one who gave us a relief on these problems that we used to face before he came out with those fundamental principles on how to solve problems in terms of mechanics. This, I'm just trying to show you that that is a machine that you can see there. It's a crane lifting something which is, I think, that looks like a river. The mechanical guy who designed that train understood the principles of engineering, because there are two things that can happen there. If the load this load here, it is heavier than the capacity of this equipment, of course, all of us, we know what will happen. This thing will collapse. So the mechanical engineer understood the forces that are supposed to be applied without the machine itself failing or collapsing. So basically, you'd find that most of the infrastructure, machine systems, most of them, they are designed to be in equilibrium. I'm sure all of you know the word equilibrium. This is just an overview of mechanics. You need to appreciate the type of mechanics. Of course, the third one, mechanics of fluids, we won't touch that one. This one, it will be a course in third year and fourth year, if I'm right. But for C22119, we'll only look at the first two components, that is statics of rigid bodies, and the second one, which is the mechanics of deformable bodies. The two parts of mechanics of the rigid bodies, there are also two parts, which is the one which is statics and the other one which is dynamics. The only difference between these two is for dynamics, it is looking at bodies that are on acceleration, that are on motion. But for statics, these are bodies that are at rest, or maybe they might be moving without acceleration. All of you understand that from physics, the difference between velocity and acceleration. So, under C2219, we'll concentrate on statics. That is the first component. Dynamics is another course in third year. Then the second component, which is the strength of material. Of course, this will be done by Mr. Lungu. It's also very important for you to understand what type of material are you supposed to use. For an example, if you are building a bridge, what type of material are you supposed to use? Are you supposed to use concrete? Are you supposed to use I-beams? Okay, if I want to use concrete, what is the strength of that concrete? How is it going to fail? If I apply this load, how much is it going to deform? That is the second component. So, in this course, we'll look at statics and the strength of material, not any other. Now, the first component, which is statics, it will give you, so after 10 minutes, like for now it's I think 9 minutes remaining, I'm going to share another link. I hope that is clear. So the first component, which is statics, is fundamental for the mechanics of material. If you don't understand this first component, if you are lost with the first component, then you are going to have problems with the next component, which is the strength of material. So the two that you need to develop from statics, that's the same two that you are going to use as you are solving problems on mechanics of materials. Statics deals with equilibrium of bodies. That is, it is used to determine the force acting either external to the body or within it that are necessary to keep the body in equilibrium. In short, this equilibrium thing, any building that you have seen, you go to East Park Mall, you go to arcades, you go to in town, you see a lot of buildings. Those buildings are standing today because they are in equilibrium. Whichever load that you apply to that building, it won't fail. Why? Because it has been designed in such a way that the maximum load that you are going to apply to that building, it won't fail. That is equilibrium. Even your bridge here, which is just across as you are going to Kalundu, that bridge was designed in such a way that you can be crossing the road using that bridge without the bridge itself collapsing. So that bridge is in equilibrium. There is an important component there on that bridge. It is being supported by cables. I'm sure you have seen those cables. We'll have a component where you will be able now to understand the force in a cable, the force in a rope. And not that a rope will always be in tension. Always, not that. A rope will always be in tension and not compression. Now, if you don't understand tension and compression, just have some patience. Statics looks at bodies, rigid bodies that are or that have no acceleration. The basic quantities used in mechanics. Of course, one, there is space, there is force, and what else? What other quantities can you remember?
And mass.
That's one of the quantities that you can use. The other one,
Time.
that's also another quantity. The other quantity that we normally use when solving our problems, our engineering problems.
Length.
Thank you. These four, they are the most fundamentals because most of them, like a force, it can be derived from these quantities, right? So we can pause. I share the other link, then we continue. Thank you.